Okay, experimental versus theoretical probability. Experimental probability. This means you are actually doing an experiment. You might roll a dice 100 times and record how often you get a 5. Think of the game Yahtzee and you're rolling the dice and recording all of your different outcomes you get as you roll those dice. Use a tally chart or a frequency table to record the data. Your experimental probability is your ratio of the number of times that your event occurred out of, remember that fraction line means out of, that's a trigger word, total number of trials. So, example, I toss a coin 300 times. 140 times it is heads. The experimental probability, 140, my event occurred out of 300. I can reduce it to simplest form. I can convert it to a decimal, and I can convert that to a percent. Theoretical probability. This is the ratio of the number of ways an event can occur to the total number of equally likely outcomes. Remember the word theory. It's in theory, what should happen. Not necessarily what always does happen, but what should happen. Theoretically, ratio of the number of ways an event can occur to the total number of equally likely outcomes. Vocabulary. Equally likely? Well, this is when the possible outcomes have an equal chance of occurring. So that means that everything that I do, so a dice, every single side of the dice has an equal chance of occurring. I flip a coin, both sides have an equal chance. Theoretical probability, the number of ways that the event can occur out of the total number of equally likely outcomes. So don't worry about the textbook at the bottom. That's just for my class. An experiment is considered fair. Let me go back because we need an example here. If I'm going to roll a dice and I'm going to roll the dice 25 times, or let's say I'm going to roll it, let's do it 100 times. How many times should a 1 come up out of 100? It should come up 1/6 of the time. So 1/6 of 100. Make it easier. I roll the dice 6 times. How many times should a 1 come up? Once. 1 out of 6. So theoretically, I should have a 1 out of 6 chance of getting any single side of the dice. An experiment is considered fair if the outcomes are equally likely. Example, a coin or a dice. You have to account for all outcomes. Therefore, the probability of your event plus the probability of not your event has to equal 100%. Either it happened or it didn't happen, but together they add to 100%. The term complement means not your event. Do you notice we have a lot of vocabulary in math? And without understanding the vocabulary, you can't understand what the question is on a test. You have to know what the vocabulary means. Complement means not your event. So the probability of your event plus the probability of the complement, which is not your event, has to equal 100%. Remember, we talked about using the capital P with the parentheses to say the probability of something occurring. How about odds versus probability? Odds, your event out of not your event. Probability, your event out of total. This is huge, everybody. You need to understand that there is a very big difference between odds and probability. They are not the same. You go to a casino and you say, well, what's the probability I'm going to win? That is very different than the odds of you winning. So let's take a look at it. Your event plus not your event, otherwise called complement, equals total. So the probability of your event plus the probability of not your event, complement, equals 100%. Here's an example. I have these flags. I have red flags and I have green. The probability of red, so notice the P and the capital R. Your event, there's 4 red out of total, 4 out of 7. You can make that into a decimal, into a percentage, whatever you would like. But the odds of red, this means red and not red. Look up at the top, your event and not your event, 4 to 3. We are not turning this into a decimal or a percent because now this is a ratio, 4 to 3, 4 to 3. It can be written 3 different ways, as a fraction, as a ratio, as a sentence, however you want to write it, but 3 different ways. What if I need to convert probability to odds and odds to probability? I have this all on one slide because this is review. Again, if this is the first time you're seeing this, please pause the slide and really look at the information. You only need 3 pieces of information. Your total, your event total, not your event total, and your total trials. Your event plus not your event equals total trials. If you have 2 pieces, any 2 pieces, you can use algebra to calculate the missing number. That's just simple, find the missing variable. The odds of winning are 3 to 1, which means that I win 3 times and I lose 1 time. The probability of winning, 3 out of 4, 75%. I win 3 out of 4 times. Notice that the total is used for probability and the pieces are used for odds. Take your time with this, but boy, is this great information when you're taking a standardized test. You need to remember that odds and probability are 2 separate values. Bye now.